is day 8 in Algebra 2. So I'm going to title my note page. Oh my gosh, I'm using the wrong. I have a notebook. I forgot. I've been trying to keep it organized this term.
So you teach geometry too?
I do, yes. I used to teach all 4 of the subjects, but now Sylvia's here, so that kind of lightened my load.
Yeah. I was trying to think. I think they told me that I was gonna have to take geometry too eventually.
Yes.
I'm like, man, here we go.
Now I'll tell you what, and every student I've ever had agrees with this. If you take Algebra 2 first, like y'all are doing, geometry is about 20 times easier. So, really, I promise you, geometry is not as hard as Algebra 2. Because Algebra 2 is like we're learning how the numbers work and all the relationships and all the equations, and it's a lot of rules. But geometry is like, now we know all the number things. Let's apply it to shapes, like triangles, and it doesn't get too complicated. I think geometry is usually kind of a break after everything. And I'm going to title this as Unit 2. We're starting Unit 2. And I will put a date on this. What is it? Thursday, October 16th. That's crazy. Halfway through October. Getting closer to Halloween. Okay, Thursday, October 16th, and we're on day 8. We're a third of the way done with Algebra 2. It goes quick. So we are going to also put a title below all this that says quadratic. So quad as in 4. Quadrat. I see. Quadratic. Okay. So quadratics, we saw a little sneak peek of quadratics on your bonus question for Unit 1. And in Unit 1, we didn't deal with too many quadratics. I'm going to write on a little sticky note. You don't have to write this part, but I just want to refer back to the types of equations that we've been dealing with so far. We've had equations that look like this in standard form. We've had equations that look like this, y equals mx plus b, in slope-intercept form. We've done both of these whenever we solve systems. But now I want to put that to the side, and we're going to look at one more kind of equation in this unit. And we write that with a lowercase a x squared. Now we add an exponent in, ax squared. And we have plus lowercase bx plus lowercase c. It's usually equal to 0. That's what we like to put it as. Ax squared plus bx plus c. The very first thing that we're going to practice doing, it may seem simple, but this is so important. We're going to practice looking at quadratic equations and just identifying what would be considered the number that is A, what's the number that's B, what's the number that is C. So we're just going to be looking at where the numbers are in the equation. And we're going to pull out this little worksheet. And we're going to look at number 1 on that worksheet, and I'm going to copy that problem on to my note page. So, underneath here, I'm going to write negative 5x squared minus 12x plus 65 equals 0. And then I'm going to pull out some highlighters. Use blue and green. Doesn't matter if you're using the same colors or not. But I'm going to make my A pink. My B green. Gosh. I hate when that happens. Pink, green, blue. That green must have filled up. Wow. Little gross looking there. Okay, so I have A, B, and C. If I am looking at this first example here, and my question to you, or my directions to you, were to identify the numbers for A, B, and C, let's start with what number would be my A? -5. -5. Good. So I'm going to highlight that in pink. -5 is A. What would be my B? -12. Good. So making sure that we pay attention to signs. -12 is B. And what would be C? 65. There you go. We can identify A, B, and C. So off to the side, you might write these numbers down. A, 5. B, -12. C, 65. So being able to identify these numbers is going to be very important later on. Let's do another one for funsies. I'm going to write another example below that, and it'll be from number 2 on the worksheet. I have 6x squared minus x minus 117 equals 0. I wanted to identify my values for A, B, and C. What is the value of A? 6. What's the value of B? Yes. -1. There's no number here in front of x, so we always assume that means there's a 1 there. And what would be my C? Good, -117. So I'll write those out again. A is 6. B is -1. C is -117. Okay, so we can identify A, B, and C. With being able to identify A, B, and C, we can do a lot of things. And the first thing that I am going to show you, I'm going to put it on a sticky note. And I would recommend that you guys write this down, whether it be on a sticky note or on your note page. But I'm going to give you a formula. And this formula is called the discriminant. DIS. D-I-S-C-R-I-M-I-N-A-T. Discriminant. And your formula for the discriminant is capital D for discriminant equals B squared minus 4AC. Hello. We have a handout up here on the wooden table. We're going to use that just to give us our problems for notes. We just started day 8 notes for unit 2. So here's our discriminant formula. I'll leave that up for a minute while everybody finishes copying down what we have, getting ready to use that. So we have our discriminant formula. Let's use this. I'm going to put this over to the side, and I'm going to look back at my equation in number 1. I have, again, negative 5x squared minus 12x plus 65. If I said find the discriminant, we're going to use A, B, and C and plug them into this formula I just gave you. So I'm going to write D equals, I know I'm going to write B squared. So here's B squared. What number am I putting in for B? Negative 12. Negative 12. And that's my B. The next part of my formula says minus 4. That minus 4 will always be there. And then I have A and C, and those are being multiplied to that minus 4. So I'm going to put in parentheses for A. Yes, negative 5. And parentheses for C.
65.
65. Good. So once you have everything plugged into your discriminant formula, what's kind of nice about the way the formula is laid out is we can basically solve this from left to right. Because the order of operations tells us first we do any operations in parentheses. These parentheses don't have operations in them, right? They're just separating our numbers. So the next thing we look at is exponents. And there's an exponent right here. So I have negative 12 squared. How could I find negative 12 squared? What does that really mean I'm doing?
Negative 12 times negative 12.
Yes. Okay, I hear 2 different things. Multiply by 2 or negative 12 times negative 12. Very common mistake we might see is that you see a squared and you think, I'm just going to take this number times 2. This is not negative 12 times 2. This is, like you said, Charles, negative 12 times itself, times negative 12. So, when I type in negative 12 times negative 12, like this, I hit enter, I get positive 144. Now, here's where I will see mistakes, is if you type, get this, focus on my calculator. If you just type negative 12 and then use the squared button, watch what happens. When I hit enter, I get negative 144. Which is the right number?
The positive.
Positive.
The positive. Yes, the positive number is correct. Do not get a negative number because what is happening here is your calculator does things according to the order of operations. It's seeing 12 squared. Okay, 144. I still have a negative sign. We'll bring that down. Really, exponents are telling you how many times to multiply that number to itself. So, negative 12 times negative 12 or negative 12 squared is positive 144. If you want to use the squared button, you will also need to use parentheses around your negative number. Then you can square it, and now it will give you the correct answer. Because now your calculator sees, oh, I'm squaring the whole thing, not just 12. So, negative 12 squared is 144. So I'm going to bring that down. And I'm going to cross out negative 12 squared so I don't forget that I'm done with it. And now the next part of the discriminant is we have basically negative 4 times negative 5 times positive 65. We can type these three in all at once. So I will do that. Negative 4 times negative 5 times 65. Hit enter. And I get 1,300. So whenever I bring that number down, if you get a positive number like we did here, we put plus. Good. So it'll be plus 1,300. If I had gotten a negative number, I would have wrote minus 1,300, but this is positive because that negative 4 and the negative 5 cancel, become positive. So I'm done with those three numbers. And what do you think I would do here? Just add them together. 1,300 plus 144 is
444.
yes, 1,444. And that is our discriminant. That's not too bad. Okay, I'm going to leave that up for a second, let everyone catch up, and then we'll try to find the discriminant on the next one. So I have found my discriminant. So let's practice that one more time with the next problem. And we're going to use that discriminant formula again, b squared minus 4ac. And this time I'm just going to write it right here. D equals b squared minus 4 times a times c. Now, b equals, I'll write it without the letters so that I have blanks to plug into. Just like this. So, once we have all these blanks kind of written out, somebody tell me, what am I plugging into each blank?
-1 for B.
Good. -1 for B.
6 for A.
6 for A.
And then -1, 17 for C.
-1, 17 for C. Good. I'll color these. B. A. So we'll do the same process as before. We'll just go from left to right, starting with -1 squared. So -1 squared, bless you,
Thank you.
that's just -1 times -1. What will we get? Positive 1. Good. So I'll cross that out and bring down 1. Bless you.
Thank you.
Hey, we allergic to math over there.
All right. Now I have -4 times 6 times -117.
2,808.
Oof, 2,808. Is it plus or minus?
Plus.
Yeah. Plus, you said 2808?
Yes.
Okay. 2808. Okay. And we're using plus here because -4 and -117, those are two negatives in our multiplication problem, which will cancel to be positive. That changes the -4 into a plus 2808. So what's our discriminant?
2,809.
Yes. Now we just add 1 plus 2,808 and we get 2,809. There you go. Now, this probably feels like, okay, we got a discriminant. I don't even know what that means, though. We're going to move towards understanding what that means next. So we have a discriminant. What is a discriminant? So let's give you another formula here. And the next formula is this. I'm going to write it on this sticky note again. And we just did the discriminant formula, but now we're going to use what's called the quadratic formula.
Highlighters still.
You need new highlighters?
We're too late in the game now. I didn't use the mucky colors to feel that thing.
I know, I need to restock on highlighters too.
It just drives me crazy when I use these and I highlight it and the black blends in with it.
Ugh, I know, that bothers me too. Icky. Okay, so the quadratic formula, this is probably the formula that everyone gets the most scared by. But I promise, there's a song I'm going to teach you. And you're going to sing to me today.
Oh.
Whether you like it or not, you're going to sing, and I'm going to sing with you. But here's the formula.
On the recording.
Nobody's going to see it but us. It's okay.
It's a happy memory.
Okay, so the quadratic formula. This is the formula we're going to use to solve for x. Because something we noticed when we had that bonus question on Unit 1 was that when you have an exponent in a equation, it makes things a little complicated. So having a formula to follow can make it a little bit easier, even if it looks harder. So x equals, this is going to solve for x for us, -b. So whatever b is, the formula changes it to a different sign. For example, this last problem, b is -1. If I put -1 into this formula, because there's another negative outside of b, it'll become +1. That's something to keep in mind as we do the rest of the formula. X equals -b plus or minus. New symbol. The square root, start with just a check mark, of d, of discriminant. That's what we'll keep it as for now.
I don't remember anything square root.
Oh, shoot.
So -b plus or minus the square root of the discriminant. All of this is divided by 2 times a. That's the formula. I used to teach it in a way that was even scarier until I realized this shortcut. I'm going to show you the original formula that we all had to memorize. x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You see now why I like to teach the discriminant first, because then you're not doing 20 million steps at once. You can do the discriminant and then just plug that in, because the discriminant is b squared minus 4ac. So why not just write discriminant? Makes it a little bit less complex and scary looking. But something about this formula that makes it hard is because there's a lot of kind of moving parts. And working with it can be a little bit tricky. So I never will make you memorize anything, ever, because you can use your notes. But this is the one formula that having it a little bit memorized will actually help a lot. So this is where the song comes in. And I'm going to sing it to you.
Yay.
So it goes to the tune of Pop Goes the Weasel. Pop goes the weasel. And how we're going to do this is I'm going to zoom in real close on the more complicated formula. And when I was in high school and learning this formula, this is how I was taught it. And I've never forgotten the formula because of this song. It will stick in your brain forever.
I still have a pen that song.
Right. The songs, I swear.
That's a platinum hit.
Okay, so I'm going to put it to where this is all we can see. And it goes like, you make it not blurry. A little better. All right. So the song goes like this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
I definitely heard that.
You heard it?
I've definitely heard this before.
Sound familiar? Okay, so here's how we're going to do this. I can turn the recording off now. Okay. So, back to it. Let's use this formula. We're going to go to a fresh page of paper, though, because the first time that we ever use this formula, it is a little bit less scary to have some blank space to work on. So, I'm going to zoom out here, and I'm going to flip my page.
Is it gonna take up like a lot of pages?
I'm not sure. It kind of depends on how big you write
I'll
it.
just rewrite the entire notes if it doesn't work.
That's fine. I do it all the time. Okay, so page 1. Now I'm going to start page 2.
So,
So page 2, and I'm also going to write that these are the day 8 notes. Continued. And once we solve for x with 1 or 2 problems here, we're at the very end. I'm going to let you go after this. Early day. Okay, so we're going to go back to the very first problem that we did, where we got, I'm going to rewrite the problem real quick. Negative 5x squared minus 12x plus 65 equals 0. And we identified A, B, and C. We said A was negative 5, B was negative 12, and C was 65. Now, we did already find the discriminant on the previous page. What was the discriminant?
1,444.
Yes, 1,444. So when you use the quadratic formula, you can, and I would recommend you do this, I would find the discriminant first. Then I would plug in to the simpler quadratic formula. You can do it all at once, but when you do, I see more mistakes I do, because it's more things to do at the same time. So let's use A, B, C, and D. Okay? That way we have easier time with formula. So I'm going to copy down x equals negative blank space for B. What goes in the first blank? Negative 12.
So it'd be negative?
Yes, negative 12.
Would make it.
Yes, it will change it to a positive 12, but we'll do that at the next step. So I have x equals negative B plus or minus. Next, I have the square root of the discriminant. So we're going to write the square root of 1444. So we plug in two things. And now we just need to draw a big fraction line under both of these. And the last thing to plug in is 2 times A. Yes, 2 times negative 5. And I'm going to do a little bit of color coding again because it just is going to make it a lot easier for me to look back at later. I made A, B, A, here, A, here, B, green. E we don't actually use unless we're doing the discriminant or if we're using the longer version of the formula. Okay. So once we have things all plugged in, I guess I could make the discriminant another color like orange. So we plug 3 numbers in. And now we're going to simplify each individual step. So first what I would look at is my negative 12. What does this become? Positive 12. It's like we're distributing the negative. We could also think of this as negative 1 times 12 or times negative 12. This becomes positive 12. So below this, I'm going to write x equals 12. Positive 12. The negatives cancel. That little arrow to show that that's where that came from.
And then since the 1444 is a positive, it'd be plus, right?
It would be less, you said?
It would be plus, like you would add it.
Ooh, okay, very good question. We're thinking about this plus or minus now, right? So we will do something with the plus or minus, but not yet. Right now, we're actually going to bring down both. Feels weird, but we are. We're going to write plus or minus. After that, I have the square root of 1444. Can we simplify that? Can I figure out the square root of that? The answer is yes, you can. And I'll remind us again how we find the square root on our calculator. Whenever you are looking at it, you're just going to hit the blue second button and the button that says x squared. There's a little square root above it. Now you have a square root on your screen. We'll just type 1444 and hit enter.
What was the second step?
Second step is where it says x squared. You just push that. So second, x squared. That gives you your square root. And then enter, and we get 38. I love it when it's a nice number. A lot of times we'll get decimals for that. So the square root of 1444 is 38. So I'm going to bring down 38. I don't need my square root anymore because we used it. We used it to get 38. And now I just have one last step. What else is left to simplify? The bottom, 2 times -5, which is -10. Okay, so if it helps again to see where these numbers are coming from, you can do arrows, I'll do colors again. I know it's not A, B, and C anymore, but color code to show that that is where each of the numbers came from.
When we're doing our tests and stuff, like our quizzes,
Yes.
can we do colors on that?
Absolutely,
Okay.
yes, absolutely. I encourage it.
Imagine if she was like, no, I can't use any
Like,
colors.
absolutely not.
Absolutely only black and white.
Actually, I love it when you guys
Like,
do
yes,
use colors
yeah.
because it makes it easier for me to grade. I can see your work better.
Okay.
I'm a color girl. I gotta have colors. Okay, so now at this step, I have a complicated looking fraction. 12 plus or minus 38 divided by -10. So there's a few things we could do here. We could see if we can reduce this by kind of dividing. Like I see these are all even numbers. So I could divide this by 2. And I could have like 6 plus or minus 14 over -5. You don't have to do that though. If you like simplifying fractions, great. I usually don't teach to do it because it just gives you another opportunity to make a mistake. I'm going to say at this point, once you have no more symbols, all you have is numbers, like we have here, we're going to separate our plus and our minus. So, this is where I draw 2 equations. There's going to be a plus and there's going to be a minus.
Hi.
Hi, Lewis.
I'm sorry.
How you doing?
Good.
Good.
Glad to see you. I've only had
Okay, so whenever we separate into the plus and minus, we're not going to change any of the numbers. We're not going to change any positions. The only thing we're going to do is rewrite the problem twice, but with one, we'll have a plus sign. With one, we'll have a minus sign. This is where we get the 2 answers. So I'm going to write for plus 12 plus 38 divided by -10. What do you think I'll put for the minus?
12 minus 38.
Yeah, 12 minus 38 divided by -10. And we're almost done. We're almost done. So I have my 2 problems. And now we just have to make sure, this is one mistake I will see, is the student will type in 12 plus 38 divided by -10 in their calculator all at once. You cannot do that because your calculator will do 38 divided by -10 first. And then it'll add 12 because of the order of operations. So when you have a fraction, we have to simplify the number on top first. So first I'm going to do 12 plus 38, which is 50. Then bring over, divide by -10. And what's 50? Yes, 50 divided by -10 is -5. One answer. Now I'm looking at my minus problem, 12 minus 38. 26. Almost. Good. -26 divided by -10. Yes, those negatives cancel. We get positive 2.6. And you're done. That's it. So your answers are x equals -5 and 2.6.
2 answers.
There's 2 answers for x. And I'm going to show you why there's 2 answers for x. what we just solved for here is if I were to graph this equation, we solved for where the graph touches the x-axis. And because the graph of a quadratic equation looks like this, which we won't talk about much today, it looks like, here's my graph. If I were to graph it, it would look about like this. This is the x-axis. So one x value is right here at about -5. Another one is about here at 2.6. That's what the graph would look like. So
Wow.
that's why we have two x values. Kind of cool.
Okay, when you said graphing, I was like, all right, now it's making sense.
Yes. Sometimes the visual helps because what we're doing right here feels like it's all up in the air and it doesn't have any context. But what's happening is we're finding where the graph is touching the x-axis in two spots. So x is -5 and 2.6. And that's your answer. And that's it. So guys, I'm going to say that's been our sneak peek at Unit 2. So we will do more with this on Monday and next week. But for today, that is all I'm going to give you. If you are completely caught up for this week, meaning you have turned in the day 5 exit ticket, you've done the Unit 1 practice quiz, and you've done the Unit 1 quiz, you are free to go. If you still have things to work on, please stay and come see me if you're not sure what you need to work on. But we're going to use the rest of today kind of like office hours. Teachers are not available tomorrow. We have meetings all day. So today is like your Friday. But you're free to go or to stay. I'll be here to help.
I just hang